Okay. So these are all the four problems we are going to discuss today. So 5 questions are there. And before we go to the topic, could you please recall the formulas? What is the formula for calculating the electrical field? The definition for the electrical field E, which is equal to force per unit charge. Am I right? Or force per charge. What is the formula for calculating the force? Force which is equal to Q naught multiplied by E or Q multiplied by E. Both are correct. Clear? And then the formula for electrical field due to a point charge, E, which is equal to KQ over, that means magnitude of Q over R square. And what is the formula for dipole moment? The dipole moment, which is nothing but magnitude of any one of the charge multiplied by the distance between the two charges. And then formula for the torque effect, it's P cross E or PE sin theta. So these are all the formulas we are going to use in these problems. I think we don't have any question from these three. We don't have any question from these three formulas, but generally we may ask the definition in the final exam. Define dipole moment. What is the formula for torque effect for the charge as well as the dipole moment? So these things we can ask. So these information inside the box, we may ask the question from the knowledge part. But today we are going to solve these 5 problems and we are going to use these 3 formulas. So please listen carefully, and out of these 5 problems, and this problem is a little bit lengthier and it's one of the important question also. So in this chapter, in this problem, we are going to discuss many information. So please, my dear, I need the answer from your side. So please take the calculator and put it near to you. I need the answer from your side. And also I will ask you some question and you have to respond me. Understand? Clear?
Yes, clear. Okay.
Okay. Now let's start with the first question. I can just close this. Let's start for the first question. What is given in the question, my dear? First of all, try to analyze what is given in the question. What is given in this question? A charged particle creates electrical field of magnitude 300 Newton per Coulomb at a distance, that means at a point 0.8 meter away. My dear, listen carefully. You have a charged particle. You have some charged particle, whether it is positive or negative, and these charged particles exhibit the electrical field effect of 300 Newton per Coulomb at a distance of 0.8 meter. My dear, listen carefully. At a distance of 8 meter. At a distance of 8 meter. For example, you consider this is my distance. So in this point, what is my electrical field? My electrical field is 300 Newton per Coulomb. Understand?
Yes.
Is it clear? Okay. And what is the distance? What is the distance? My R value?
0.8.
0.8 meter. Okay. What is the difference in the field magnitude between that point and one at 0.4 meter? So you have another field at a distance of 0.4. My dear, for example, at a distance of 0.8, I got this field. Then what is the distance? What is the electrical field at a distance?
It will be the half.
What is the distance of 0.4 electrical field? Is it greater or smaller?
Smaller.
For example, my dear, listen carefully. I will repeat it again. Please listen carefully. You have the electrical field effect of 300 Newton per Coulomb at a distance of 0.8 meter. So what should be the electrical field at a distance 0.4? Whether it is smaller value or greater value?
Smaller. I think
smaller. My dear, whenever you come closer to the charge, your electrical field will be the greater value. Whenever you are moving away from the charge, your electrical field will be weaker value. So what should be the value of this? Is it smaller or greater? Greater. So what I am going to do, my dear, what I am going to do, I am going to name these charges. For example, you can see here, I am going to take this is my E1, this is my R2, R1. Okay, at R1 distance, this is my electrical field. So at R2 distance, what is my electrical field? Clear? So first I am going to find this E2, and then I am going to find the difference between these two electrical field. Clear? So once I find the value of E2, then I am going to find the difference. What is the difference? The difference is nothing but which one will be greater minus
E2 minus
smaller.
E1.
Clear? So let's, because from the diagram, from the picture, we know our E2 will be greater. Why? Because it is very closer to the charge. So for sure, the formula for the last one is nothing but E2 minus E1. Am I right?
Yes.
Am I right
Yes.
or not? So first thing, we are going to find the value of E2. Once I find the value of E2, I am going to find the change in difference in electrical field. So what I'm going to do, we know the formula for calculating the electrical field. What is the formula, my dear? E, which is equal to K magnitude of Q over R square. This is the formula. Am I right?
Yes.
Yes.
Am I right? Okay,
Yes.
I'm going to apply this formula for this E1 and R1. I'm going to apply this formula for E2 and R2. First, I'm going to apply for E1. So what should be the value? So what should be the value, my dear? E1, which is equal to K Q over R1 square. Am I right? I'm going to name this as my first equation. Likewise, I'm going to apply the same formula for this E2. So what should be the value for E2? My E2 value, which is equal to KQ over R2 square, because charge remains the same. So I'm going to keep as it is, and there will be no information about the charge value. Am I right? Am I right or not?
Yes.
Okay, now what I am going to do, I am going to, because we are going to find the value of E2. So what I am going to do, I am going to divide the second equation by first equation. So what I am going to do, I am going to divide the second equation by first equation. So what is my second equation? So I am going to divide the second equation left hand side with right hand side by the first equation left hand side. So what you will get? E2 divided by E1, which is equal to my right hand side of the second divided by right hand side of the first. So what you will get, my dear? KQ over R2 square divided by KQ over R1 square. Am I right? Am I right
You
or
will
not?
get R2 square over R1 square.
Yes. So let's we just work out this. So both are in the division form. So if you just expand this equation, if you rearrange this equation properly, E2 over E1, which is equal to how your equation becomes KQ over R2 square multiplied by, this will come to the numerator. Am I right? So R1 square divided by KQ. Am I right? Am I right or not?
Yes, you
Yes.
are.
So this KQ get cancelled. So what is remaining, my dear? The remaining will be E2 over E1, which is equal to R1 square over R2 square. Now we are going to find the value of E2. So I am going to move this E1 to the right hand side of the numerator. So my equation becomes E2, which is equal to E1 multiplied by R1 square over R2 square. Clear? Clear, my dear? So what is the value of E1? The value of E1 is given. What's the value?
300.
What is the value of R1? 0.8.
0.8.
What is the value of R2?
0.4.
0.4. So I'm going to substitute the value here. So if you substitute, what you will get, my dear? My E1 value is 300. My R1 value is 0.8 square, and divided by my R2 value is 0.4 square. So I will get the answer if you just work out with your calculator. So please, my dear, check the answer with your calculator so we can confirm our answer. So 300 multiplied by 0.8 square divided by 0.4 square. I got 1200. Did you get this value? Did you get this value, my dear?
Yes. Yes.
Yes.
Okay.
Yes,
Now we got the value of E2. So what they need in the question? What they need? They need the difference They need the answer in the difference form. So what is the difference in the field? So we have to use this rule. We have to use this rule. So what is this rule, my dear? So our rule is delta E, which is equal to greater minus smaller. So here greater is E2, smaller is E1. My greater value is 1200. My smaller value is 300. So what will be the value? It's 900 Newton per Coulomb. And this is the answer for the first question. Clear?
Yes, clear.
Clear? Understand?
Yes.
Okay. So now we have to jump to the second question. My dear, second question is one of the important question, and it is a very lengthier question also. We have some picture. So please, my dear, I need the answer from your side. So let's read the question. What is given in the question? Read it very carefully. In the figure, what figure? This figure, okay? So in the figure, the four particles form a square of edge length A. So you can see I have four charges in the form of square. If you connect it, it will be like a square shape. Am I right or not? Am I right or not?
Yes.
It's like a square shape. And in square, what is the rule, my dear? If you take a square, all sides are equal and all diagonals are equal. So this is the diagonal. So your diagonal will be equal and your sides are equal. So all sides will be equal, your diagonals are equal. So that's a very, very important information. So please, my dear, listen carefully. It's very, very important. So I can just delete this first. Okay. Let's rewrite what is given in the charge. What is the value of charge? What is the value of the charge? Q1 value 30 nano coulomb. What is the meaning for nano? 10 to the power of minus 9 coulomb. My dear, please listen this question very carefully. It's a very lengthier question and it's one of the important question also. So what is the value of Q2? Minus 15 nano coulomb. What is the value of Q3? Plus 15 nano coulomb. Q4 minus 30 10 to the power of minus 9 coulomb, and then the side, the edge length of the square shape structure is given. So what is the value of A? A is given as 5 centimeter. So you have to convert it to meter. Now what we have to find by using these four charges and this A value? So you have to give the answer in terms of unit vector notation. So you must give the answer in terms of X, Y, Z. But the diagram is given in terms of X-axis and Y-axis. So you have to give the answer in terms of I cap and J cap. So that is nothing but unit vector notation. You already studied in Physics 1, Chapter 3, vector. Am I right? Am I right or not?
Yes, yes.
Okay.
Yes.
Now, what you are going to do? You are going to find what is the net electrical field do these four particles produced at the square center. My dear, you can see the picture. If you connected these charges, it's exactly a square shape. Am I right? Am I right?
Yes.
Okay. Now what you have to find, what is the electrical field at the center of these four charges? So you have to find what should be the electrical field at the center because of this four charge. That will be the question. So what is the net electrical field? Do the particles, what particles? These four particles produce the square center, at the square center. So in this place, what should be the electrical field? My dear, please go back to your theory part. So if you want to find, because here you have 4 point charges, if you want to test the point charges, every time you have to take the test, every time you have to test this point charge with the help of the test charge. We studied these things. Am I right? If you want to test the point charge, you have to bring the test charge. Am I right? Am I right or not?
Yes, you're right.
Okay. Now what I am going to do, I am going to find the direction of the electrical field. This is very, very important. Because if you want to give the answer in terms of vector notation, the first most important thing, you must know the direction of the electrical field lines. How to find the direction of the electrical field lines? My dear, now I need the answer from your side. How to find the direction of the electrical field lines? So if you want to find the direction of the field lines, you have to bring the test charge Q0. What is the value of test charge? It is very, very small and it has the positive charge. So you have to bring the test charge from the center towards the point charge. So how many point charge you have in this picture? I have 4 point charges, Q1, Q2, Q3. All these are what is this?
Point charge.
Point charge. So if you want to test the point charge, you have to bring the test charge from the center, because we are going to find what should be the electrical field at the center. So what I am going to do, I am going to take this test charge, I am going to move from the center towards this Q1. My dear, my point charge here, Q1, what is the value of point charge here? Positive or negative?
Positive.
Positive.
Positive. What is the value of test charge?
Positive.
Positive.
So if you bring the test charge from the center towards this point charge, both will be positive. So what will happen?
They will go away from it.
It will be
Yes.
repel. So the
Yes.
direction of the electrical field of Q1 will be this. Am I right? Am I right or not?
Yes,
Okay.
you are.
Clear? Okay. Likewise, I am going to test the remaining 3 charges like this. I am going to take the test charge and I am going to towards the direction of this Q1, Q2. What is the value of Q2? Positive or negative?
Negative.
So
Negative.
negative and positive, what will happen?
It will go the same direction.
It will be attract. So it will be going here. Am I right?
Yes.
Am I right or not? So this is my E2. Now I am going to take the test charge. I am going to moving towards Q3. What is the value of Q3? Positive or negative?
Positive.
What will happen?
Rebel.
Repel. So this is the electrical field direction of Q3. Likewise, I am going to bring the test charge from the center towards this Q4. My Q4 is negative. So what will happen? What will happen?
Attract.
Attract.
Attract. So now you know the direction of the electrical field lines. Am I right? Am I right or not?
Doctor,
Yes.
I don't
Yeah.
understand. I don't understand the E1, E2, E3. This one.
If you don't understand, did you listen the class, theory class, my dear?
The last week,
Yeah.
yeah, I listened, but I forgot.
Well, if you attend the class, then your question is not correct, because
Yeah.
I explain everything clearly. Okay, I will repeat it again. Please listen carefully. Okay, my dear? Clear? Okay, listen here. How many point charge you have here? I have 4 point charge. My dear, listen carefully. I have 4 point charge. Q1, Q2, Q3, Q4. I want to test. So if you want to test this point charge, what you have to do? You have to use the test charge. So what we are going to do? We are going to find the electrical field at the center of the square. So that means in this point, we are going to find what should be our electrical field. Am I right? Am I right?
Yes.
Okay.
Yes.
So what I'm going to do, from the center towards each charge, I am going to bring this Q naught. So I am going to take one Q naught. I am going to move towards the direction of Q1. So my Q naught is always positive. And what is the value of Q1?
Also
What is the value of Q1?
positive.
So what will happen? Positive and positive. What will happen?
Repel.
My dear, if I ask you a question, please respond, my dear. You are asking me, you don't know. But I am asking you the question, but you are not responding. What can I do?
Positive with positive, positive also.
So positive is test charge. My point charge here, Q1, is also positive. When you move positive towards positive, what will happen?
It will rebel.
They will go from each other.
What?
They will go
Rebel.
away from each other.
They will repel. So that means the repulsion will be in this direction. Am I right?
Yes, you are.
So this is the electrical field 1 because of point charge Q1. Clear? Clear?
Yes, clear.
Yes.
Okay. Likewise, you are going to move the test charge from the center towards the point charge Q2. My test charge is positive. my point charge Q2 is negative here. Am I right? Am I right or not?
Yeah. Okay.
So positive and negative, what will happen?
To attract.
It will attract. So the direction of E2 due to Q2 is E2. Am I right?
Yeah.
Okay. Likewise, I am going to bring the test charge from the center towards charge Q3. My Q3 is positive. My test charge is positive. What will happen?
Repel.
That means this is the direction of the electrical field E3 because of Q3. Am I right?
Yes.
Likewise, I move the test charge from the center towards Q4. So what will happen, my dear? My Q4 is the negative. My test charge is the positive. So what will happen?
Attract.
So this will be the direction of E4 due to Q4. Am I right?
Yeah, now I understand.
It's clear. So we find the direction. So because without direction, you cannot be able to find the answer in terms of unit vector notation. So first we find the direction. Now, my dear, what I'm going to do, I have to make the x-axis. So this is your x-axis. Am I right? Am I right or not? This is your y-axis. Now I am going to draw another x-axis or y-axis based on this 4 electrical field. So what I am going to do, I can change the color. I can change the color. So this is my x-axis. This is my y-axis. Am I right? Am I right or not? This is my x-axis. This is my negative of x-axis. This is my y-axis. This is my negative of y-axis. Understand, my dear? Clear?
Yes, yes.
Okay. Now, if you want to get this unit vector notation, you have to give the answer in terms of x-axis, x unit. That means the x component and y component. Am I right? Am I right or not?
Yes.
What is your unit vector, my dear? My electrical field, which is equal to my x component I cap plus my y component j cap. This is the rule. Am I right or not? This is the rule. Am I right?
Yes.
So first what I'm going to do, I'm going to find the x component, and in the second step I'm going to find the y component. Once I just find the x component of these 4 charges and y component of these 4 charges, I'm going to add together to find the net electrical field at the center. Do you get my point? So what I'm going to do, I'm going to find the x component first. My dear, how many charges you have? Could you please tell me what is the formula for electrical due to a point charge? The formula is K magnitude of Q over R square. This is the rule. Am I right? Am I right?
Yes.
Yes,
I
yes,
am
you're
going
right.
to apply this. I am going to apply this rule for 4 charges. So how many parts you will get? You will get 4 parts. Am I right? What are the 4 parts? K, Q magnitude of Q1 over R square. Am I right? For the first charge. For the second charge, K magnitude of Q2 over R square. Am I right? Likewise, third charge, K magnitude of Q3 over R square. And fourth one, K magnitude of Q4 over R square. Clear, my dear? Clear?
Yes, yes.
Yes, doctor.
But in between there is a sign. Am I right? So we have to know the x component of the sign. So my dear, now I need the answer from your side. So please give me your answer. My dear, listen carefully. First of all, we are going to find the sign of this Q1. What is the sign of this Q1? My dear, this is my E1 vector for
Positive.
Q1. Am I right? E2 vector for Q2. E3 vector for Q3. E4 vector for Q4. Am I right?
Yes.
Yes.
Okay. Now, this is my E1. Am I right? This is my E1. Am I right or not? What is your x vector, my dear? My x component of this E1 is positive or negative?
Negative.
Positive. And E2
What is the y
positive.
component? Y component.
Negative.
Okay.
Negative.
Let's we count. Okay. Let's we calculate the x component vector only. What is the value of E? What is the sign for E1 for the x? It is positive. Am I right?
Positive.
So I put positive.
Yes.
Clear? Okay. Likewise, E2. What is your x component? Positive or negative?
Positive.
So positive. Very good. What is your E3?
Negative.
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 Negative. Very good. What is your E4?
Negative.
Negative.
Negative. Understand? Clear? Clear, my
Yes,
dear?
doctor, clear.
Okay, and this is your x component. Ah, yes, my dear.
Sorry to
Why
interrupt,
you
but
take the absolute value?
Because that is a rule.
Okay.
why it's positive and negative again, please?
What is the rule, my dear? You can see the rule. What is the rule?
Yes, doctor.
Okay. My dear, this is for E1. This is the E1. Am I right?
Yes.
Am I right or not?
Yes, you are right.
Is it positive or negative? Positive x-axis or negative x-axis? If you take a graph, this is my positive x-axis, this is negative x-axis. This is my positive y-axis, this is my negative y-axis. Am I right?
Oh, according to okay, I got the idea. Thank
Positive. Okay, what is the value of this E2? My E2 is positive or negative?
According to x-axis, it's positive.
Because we are calculating only the x component, my dear. We are calculating only the x component. So just give the answer in terms of x-axis. Okay, what is the x component of E3? Positive or negative?
Negative, because it's in the left.
That's what we put negative. What is the value for E4?
Negative.
That's what we put negative. Understand? Clear?
Yes. Yes, clear.
Okay.
Thank you.
Now, this is an x component. So what is the sign for x component, my dear? You have some trigonometric sign, am I right? So if you take x component, this is cosine component. Am I right or not?
Yes.
If it is sine,
why we don't take just Q4 and Q3 an x component?
My dear, you have 4 charges. Each charges have x component and y component. So you will get a 4. Am I right or not?
Yes, you are right. Yeah.
So how you will take only 2 charges?
Parallel.
Because if you take Q1, it has 2 components, x component and y component. If you take Q2, it has x and y. Q3, x and y. Q4, x and y. Clear?
Clear, yes. I got
okay. Now, so we are taking only x component. So we have to use cosine theta. Am I right? Y component, sine theta. Am I right?
Yes, you are right. Yes.
Okay. Now I can just write the same thing for y component. Could you please tell me y component? What is the rule for y component? I can just write it here. What is my y component, my dear? E of y. I am going to write the same rule. K
Q1
magnitude of Q1 over R square. K magnitude of Q2 over R square. K magnitude of Q3 over R square. And K Q4 over R square. That means magnitude of R4. And then what is the sign? Because this is y component. What is the sign? Is it sine component or cosine component?
Sine, doctor.
So I can just write sine theta here. Clear, my dear? Don't forget about this. Okay. Now let's come for the sign. The sign, positive or negative. Now I need the answer from your side. Now you have to tell me the answer, my dear. Now you have to tell me the answer. What is the y component of this E1? Positive or negative?
Negative.
Negative. So I have to put negative here. Am I right?
Yes.
Yes,
Clear?
you are right.
What is the y component of E2? Positive or negative?
Q2 positive.
Okay, good. What is the y component of E3?
Positive.
Very good. What is the y component of E4?
Negative.
Very good. That's it. Your work is over. Now you are going to substitute the value. Clear, my dear? Understand?
Clear, doctor.
Okay. Now I am going to take the common term outside. My dear, now I am going to take the common term outside. So what you will get, my dear? So here k and r square is the common term. I can take it outside. Am I right? So k over r square, I take it outside. And also I am going to move this cosine because everything is in the multiplication form. So I can take this cosine theta here. Okay. Otherwise you will forget. Clear, my dear?
Yes.
Clear, doctor.
Okay. What is the magnitude of Q1? What is the magnitude of Q1, my dear?
30 multiplication with 10
30 multiplied by 10 to the power of 9 minus 9, and sign is here plus, and here also sign is plus. What is the magnitude of Q2? What is the magnitude of Q2?
15
multiplied by 10 to the power of minus 9, and then we have to use this minus sign here. What is the magnitude of Q3?
Also 15.
15 multiplied by 10 to the power of minus 9, and this sign I can just write it here. What is the magnitude of Q4?
30.
30 multiplied by 10 to the power of minus 9. My dear, you can see plus 30 get cancelled with minus 30, plus 15 cancel with minus 15. So this becomes 0. Anything multiplied by 0?
0.
So my x component is 0. Am I right?
Yes, you are right.
Clear. Okay. Let's apply the same thing for y component. I am going to take the common term outside, k and r square. My dear, k over r square, I take it outside, and then I just take this sine theta here just for the safer side. So what is inside? I am going to write this negative here. What is the magnitude of q1? What is the magnitude of q1? What is the magnitude of q1? 30 multiplied by 10 to the power of minus 9, and this plus sign I can write as it is. Magnitude of q2 is plus 15. Am I right? So 15 multiplied by 10 to the power of minus 9, and this plus sign I can write as it is. What is the magnitude of q3? Q3 is again 15 multiplied by 10 to the power of minus 9, and then I can just write this negative sign here. What is the magnitude of q4? And it is 30 10 to the power of minus 9. Am I right? Clear?
Yes, you are right.
Okay, now my dear, the most important thing, we have to find something. Okay, minus 30 becomes
minus 60.
So k over r square multiplied by sine theta. So this becomes minus 60 multiplied by 10 to the power of minus 9 plus 15 plus 15, 30 multiplied by 10 to the power of minus 9. Am I right?
Yes, you are right.
Okay. What is the value of minus 60 plus 30?
Minus 30.
Minus 30. Very good. So I can write minus 30 multiplied by 10 to the power of minus 9. Understand, my dear? Clear?
Yes, clear.
Now,
Clear,
the most important thing, is there any information about this R in the question?
No, but we can't
Okay.
find it.
So
No,
we
have
have to find. We have to calculate. My dear, just before I told you, this forms a square shape structure. Am I right? This is the square shape structure. Am I right or not?
Yes, you are right.
So I can take the copy of this picture again.
Doctor, the problem is given the graph of the
It will be
question.
given. It will be given. It will be given. Don't worry.
Okay.
Okay, my dear. First, we are going to find what is this R. My dear, what is R, my dear? My dear, listen carefully. We are going to find the electrical field here. Am I right?
R
And
x
this
mean
form,
x square.
this form the square shape. My dear, listen carefully. So we are going to find the R. So that means what is the distance between these two? Because we are going to find the electrical field at this point. Better I can use the letter P. So we are going to find the electrical field at the point P. We are going to find the electrical field at the point. So I can write it again. So we are going to find the electrical field. So I am going to name this point as P. So my dear, the charge between the point P and this is nothing but our R. Am I right? Am I right or not? And what is this?
Yes.
This is also R. Am I right? And what is this? This is also R. Am I right? And what is this? This is also R. Am I right?
Yes, doctor.
Am I right or not? Okay.
Yes,
So
doctor.
now, if you want to find the R, my dear, listen carefully. If you want to find the R, if you know the distance from this, you can easily find the half of the value. Am I right?
Yes.
If you know this distance, for example, if you know the distance from this point charge to this point charge, if you know this distance, the half of the distance is the point of your electrical field. Am I right? Am I right? So this is the distance of R. Am I right or not?
Yes, right.
So what I'm going to do, I'm going to name one of the triangle here. My dear, if you take a square, how many triangles you have here, my dear? How many triangles you have? You have triangle For example, you name these charges A, B, C, D. How many triangles you have here?
2, doctor.
What are they? ABC and ACD. Am I right?
Yes, you are right.
Okay, I am going to take the triangle. My dear, listen carefully. I am going to take the triangle ACD. Okay.
Okay.
Could you please apply Pythagoras theorem? Have you ever know about Pythagoras theorem?
Yes,
It
doctor.
will be, Doctor,
What is the
17.
Pythagoras theorem, my dear?
R square.
What is Pythagoras theorem? Just tell me from this triangle, my dear. What is Pythagoras theorem? My AC square, which is equal to AD square plus DC square. Am I right?
Yes, you are right.
Clear? Okay. Now, what is the value of AD?
A.
What is the value of CD?
A.
So all sides are equal. So my AD value is A square. Am I right?
Yes, you are right.
What is the value of the DC square? Another A square. Am I right?
Yes, you are right.
So what is the total? My AC square, which is equal to 2A square. Am I right?
Yes, you are right.
So what is your R, my dear? What is your R? My R
Take
is
the
nothing
square
but,
root.
okay, first we find the square root. If AC square is this 2A square, what is the value of AC?
2A.
Square root.
A root 2. Am I right?
Yes.
Okay. Now what is your R? My R
Divided
is
by 2.
AC divided by 2 is my R. Am I right?
Yes.
Okay. What is my AC value? My AC value is A root 2 divided by 2. What is the answer, my dear? A over root 2. Am I right?
Yes, you are right.
Clear? Clear, my dear? Okay.
Clear.
The second thing, what is the angle? What is this angle, my dear? Could you please tell this angle? What is this angle?
90.
Half of this 90?
45.
45.
So what is your theta value here? What is your theta value here?
40.
Clear?
Clear.
Yes.
Okay. Now I am going to substitute the value. My dear, I need the answer from your side. I need the answer from your side. So I can just write it here. So please give me the answer. I am going to substitute the value of R here. K over R square. Here we got R. What is R square? What is the value of R square?
A square over 2.
Okay, I am going to substitute. Okay. What is the value of sine 45? 1 over root 2. Am I right?
Yes, you are.
Okay, I am going to substitute the value. R square. What is the value of R square? It's A square over 2. A square over 2. This 2 will go to the top. Am I right?
Yes.
It will come like this. Am I right? And multiply
Yes, you
by
are.
sine of 45. What is the value? 1 over
1
root 2.
over
Am I right?
root 2.
And what is inside? 30 10 to the power of minus 9. Am I right? Am I right?
Yes. Doctor,
Ah,
you can delete 2 with the 2
yes,
and
yes, you can
and
delete. So I can delete this 2 with root 2. So what you will get, my dear? K root 2 over A square. Am I right?
yes, you are.
Clear? Clear?
Clear, Doctor.
Okay, now substitute the value. What is the value of K? What is the value of K? It's nothing but 8.99 or 9. Both are correct. Am I right? So 8.99 10 to the power of 9 multiplied by root 2. Am I right? And inside I have minus 30 multiplied by 10 to the power of minus 9 and divided by what is the value of A square? A is 5 centimeter. So what is the value? 5 multiplied by 10 to the power of minus 2 the whole square. Am I right? Am I right or not?
Yes, Doctor.
Am I right or not, my dear? Give your answer. So what is the value
Yes,
of A?
yes,
What is the
doctor.
value of A? What is the
5,
value of
5.
A? So I just write 5 here. Understand? Okay, now, and this is Y component. So what unit vector you have to put?
I.
J. Clear? My Y component. So could you please substitute this value in your calculator? Could you please substitute this value in your calculator? 8.99 10 to the power of 9 multiplied by root 2 multiplied by minus 30 10 to the power of minus 9 divided by 5 multiplied by 10 to the power of minus 2 the whole square. Oh. What answer you got? Nobody is trying, my dear. I am just shouting here. Nobody is trying. What happened to you? So nobody is
Doctor,
interested.
Minus
Nobody is
1.53 to the power of 10 to the power of 5.
My dear, I need the answer of you, not from the slide. Did you work out with your calculator?
Yes.
What answer you got? I got. Just compare your answer. Minus 152565.35. And what is the unit for the electrical field? The unit for the electrical field is Newton per Coulomb. And this is my Y component. So I have to multiply with J cap. Clear? So if I just want to write the value in terms of power, how I can write? Minus 1.52 multiplied by 10 to the power of 1, 2, 3, 4, 5. Am I right? Am I right or not? Clear?
Yes.
Okay. So what is your final answer, my dear? What is your final answer? Because we have to give the answer in terms of unit vector notation. So my electrical field, my net electrical field is nothing but my x component I cap plus my y component j cap. What is the value of x component? Because we got 0. Am I right? So 0 plus what is my y component? Minus of 1.52 multiplied by 10 to the power of 5 Newton per Coulomb J cap. So my final answer is nothing but minus 1.52 multiplied by 10 to the power of 5 Newton Coulomb. Clear? Clear? Clear, my
yes,
dear?
doctor.
Okay. You can just see the size of the question. You can see the size of the question, how big, how lengthy it is.
Doctor,
Yes, my dear.
how do we find the A?
A is already given in the question.
It's given. Okay.
A is already given in the question. You can see here.
Doctor, why we don't put from first equation to make it easy?
Which equation, my dear?
I mean, when we find the R,
Okay.
if we put, I think it's come easy.
It's up to you, because as a teacher, I have to explain each and every term correctly. If you want to make short, no issue, but do it very carefully.
Okay.
Clear, my dear? Understand?
Doctor. Understand.
Doctor?
The most important thing is the sign. What is the sign for Q1, Q2, Q3, Q4? That's the very, very important. Here, the sign indicates the direction of the electrical field. Understand?
Understand,
Clear?
Doctor. Clear.
Okay, let's come for our third question.
Doctor?
Yes, my dear.
Can you please repeat how did you get theta lastly?
Theta. Okay, you can see this picture. I can take this picture here.
I mean 45.
I will tell you. So better I can write AC here, because the AC part comes here. So what is the value of AC here? It is nothing but A root 2. Clear? Okay. Let's come here. My dear, this is like a square-like structure. Am I right?
Yes.
Am I right? What is this angle? What is this angle? What is this angle? What is this angle?
90.
Okay, we are going to find the electrical field here. Am I right?
Yes.
So if you connect this point, it will be coming like this. Am I right? Am I
Yes.
right or not?
Yes.
So what is
like
the half of this? What is the half of this?
45. Oh, okay.
Of course, that is because it's a square. Square give the correct angle. The square you will get 90 degree. So half of 90 degree is nothing but 45 degree.
Okay.
Clear?
Yes. Thank you.
Okay. Now we go for third question. The third question, it's very easier question, but you have to know what is given here. Let's read the question very carefully. What is given in this question? In this figure, the electrical field lines on the left hand side. So what is the left hand side? This is your left hand side. Am I right? This is your right hand side. Am I right? Am I right?
Yes, doctor.
Okay. So in this picture, the electrical field lines on the left hand side has the twice the separation on the right hand side. You can see here the distance is more between two lines. What is the distance here? Half. Am I right? So the electrical field lines on the left hand side has this twice the difference between the right. Clear? So what is the rule, my dear? What is the rule? What is the rule? My point A, because you can see here, you can just see this point. My point A, which is equal to 2 times of B. Am I right? Am I right or not? My dear, open your mouth and say either yes or no. Just give me the answer.
Yes, doctor. Yes.
Yes.
Okay, you can see because they clearly mentioned in the question, my electrical field lines on the left hand side. What is my left hand side? My B. So my electrical field lines on left hand side EB has twice the separation of A. So I can write my electrical field line at A, which is nothing but twice the time of electrical field at point B. Am I right? So this is the rule which is given in these first 3 lines. Now what we are going to do, we are going to find the answer for the first question. So what is given in the first question? And they mentioned the electrical field at point A. What is the electrical field at point A? They give the value of EA. What is the value? 60 Newton per Coulomb. Am I right? Now what you are going to do, you are going to find what is the magnitude of the force on the proton at A. You take positive charge. What is the charge for the proton? What is the charge for the proton? Positive or negative?
Positive.
So you are going to take one positive charge, you are going to place here. What will happen, my dear?
Change to the
What change?
It will go with the
Give me,
field.
give me the correct answer. I told you this point in the last theory class. If you put positive charge in the electrical field lines, your positive charge will be moving in the same direction of the electrical field lines. If you put negative charge, it will be going opposite to the direction of the electrical field lines. Am I right?
Yes, you are right.
So here they clearly mention you are going to calculate the magnitude of the charge. That means what charge? Proton. Proton has the positive charge. If you take positive charge, when you put at point A, what will happen? Your proton will be moving in the direction of electrical field lines direction. So we are going to find the magnitude of the force. So what is the formula for the force? We already know the formula for the force. What is the formula for the force? Formula for the force, which is nothing but Q multiplied by E. Am I right?
Yes,
Am I right?
you are right.
Where you put this positive charge? In point A or point B? We put the positive charge in point A. Am I right?
Yes, you are right.
So I have to write this is Q multiplied by EA. Am I right? So now what type of charge? Because charge value is the constant, which is nothing but 1.6 multiplied by 10 to the power of minus 19 Coulomb, and the electrical field at A is given as 60 Newton per Coulomb. So when you substitute, you will get the answer for the first question. Am I right? Am I right?
Yes, doctor.
So please work out with your calculator. 1.6 multiplied by 10 to the power of minus 19 multiplied by 60. What should be the answer? I got 9.6 10 to the power of minus 18. So I got the answer F, which is equal to 9.6 multiplied by 10 to the power of minus 18. What's the unit for the force? What is the unit for the force?
Newton.
Newton, very good. That's it. So don't forget to write the unit. Now, what should be the answer for the second question? What is the magnitude of the field at point B? Because field at point A is given as 60. What should be the value at B? Because they already give the information here. What should be the value of B?
120.
Half of the value of EA. Am I right? So I'm going to use this relation. So what is our relation? EA, my B part. EA, which is equal to twice the time of EB. Therefore, my EB, which is equal to EA over 2. So what is the value of EA? 60. 60 divided by 2? 30 Newton per coulomb. So this will be the answer for the second question. Clear? Clear?
Clear, doctor.
Okay. Any other question?
No.
Clear, doctor.
Okay. Very good. Let's come for our fourth question. What is given in the fourth question? Read it very carefully. My dear, in this question, we are again go back to physics 1, chapter number 2. So please read the question very carefully. An electron entered a region of uniform electric field with an initial velocity 30 km per second. What is the initial velocity? The initial velocity of the electron is given as 30 km per second. If you convert it to meter, your V naught is nothing but 30 multiplied by 10 to the power of positive 3 meter per second. Am I right?
Yes.
Okay. Now you are going to take an electron. The electron is going to enter the uniform electrical field. So better I can first write the uniform, draw the uniform electrical field. So this red color is the uniform electrical field. This red color is the uniform electrical field. My dear, if you put the negative charge, what will happen?
Go to the other side.
Go to the opposite direction. That means the electron will be moving very fast in the opposite direction of the EA. Am I right? Am I right or not? The electron is moving very fast only in this direction. But what is given in the question? The electron entered the uniform electrical field and with the initial speed of 30 km per second in the same direction of the electrical field. That means in this case, what is the direction of the charge moving? The charge electron is moving exactly in the same direction. If it is moving in the same direction of the electrical field, what will happen to the speed? It will increase or decrease?
Decrease.
Decrease.
Decrease. That means its acceleration is going to decrease. Am I right? Once the speed get decreased, its acceleration is decreased. Because according to the question, what they mentioned, electron is coming into the electrical field and its initial speed is 30 km per second. But once it moves in the same direction of the electrical field, what will happen? Its speed get decreased. So what is its final speed, my dear? What is its final speed? For sure less than the initial speed. Am I right?
Yes.
Okay, so we are going to find that information in the first question. And the electrical field value is given. What is the value of electrical field? The electrical field value is given as 50 Newton per coulomb. Now, I want to find what is the speed of the electrical field after 1.5 nanoseconds. So, time information is also given. What is the value? 1.5 10 to the power of minus 9 nanosecond. So, after 1.5 nanosecond, what should be its speed? What will speed? It will be for sure smaller than your initial speed. So what I am going to do, I am going to use the equation of the force. What is the formula for the force, my dear? Okay, for finding the acceleration, first we find the acceleration. How to find the acceleration? How you will find the acceleration? How you will find the acceleration? If you want to find the final speed. Acceleration is Newton's second law. F is equal to ma. Am I right? Am I right?
Yes.
Therefore, acceleration which is equal to F over m. Am I right?
Yes.
And what is the force of the charge? We already studied the rule. What is the force of the charge? My force which is equal to charge multiplied by the electrical field. Am I right? So in this place, I am going to substitute the value of F as QE divided by mass of the electron. Because charge Q is 1.6. The charge Q is 1.6 multiplied by 10 to the power of minus 19 coulomb. But this is a negative charge. So what should be the sign? Negative. And what should be the mass of the proton? Sorry, mass of the electron? The mass of the electron is the constant value, which is nothing but 10 to the power of minus 31 kilogram. So these two are the constant value. Now what I am going to do, I am going to substitute this value in this equation to find the value of this acceleration. So what is the value of acceleration? Q value minus 1.6 multiplied by 10 to the power of minus 19 multiplied by my electrical field is already given in the question. What's the value? What's the value? 50 Newton per Coulomb divided by the mass of the electron is 9.11 10 to the power of minus 31. So if you substitute the value here in the formula, what you'll get, my dear? What you'll get? Substitute the value and let me know the answer. 1.6 10 to the power of minus 19 multiplied by 50 divided by 9.11 10 to the power of minus 31. I got
minus 8.
Minus 8.78 multiplied by 10 to the power of plus 12. And what is the unit for acceleration? Meter per second square. My dear, we got negative value of acceleration. That means its acceleration is decreasing. Am I right? It's called deceleration. Now, once we find the acceleration, we are going to find the value of this final speed because that is given in the question. My dear, could you please go back to your physics 1, chapter 2? We studied 5 equations of motion with constant acceleration. Am I right? And out of this 5 equations, first 3 equations are very, very important. Am I right or not? What is the first equation?
Yes.
What is the first equation? V, which is equal to V naught plus AT. Second equation, X minus X naught, which is equal to V naught T plus half AT square. And third equation, V square, which is equal to V naught square plus 2 into A multiplied by X minus X naught. These equations we studied. Am I right? Am I right or not? Now, you can see I have 3 equations. First equation, we are going to find the final speed. Good. We have the initial speed, and just before we find the acceleration, time is there. But is it possible to use the second equation here? Is it possible?
No, because
we can't use. Is it possible to use the third equation? Because there is no time factor. So I can use only the first equation for finding the answer for the first question. So I am going to write the equation of the first one. So V, which is equal to, that means V here stands for V final. V final, which is equal to V initial plus A multiplied by T. What is my initial speed? It is given as 30 kilometers. That means 30 multiplied by 10 to the power of plus 3 plus my acceleration. What is the value of acceleration here?
Minus
8.78 multiplied by 10 to the power of 12 multiplied by what time you got, my dear? I think this is 1.5 nanosecond. You can see here 1.5 nanosecond. So I am going to substitute the value here. 1.5 multiplied by 10 to the power of minus 9. Could you please tell me the answer of your final speed? So that will be the answer for the first question. So I will just work out 30 multiplied by 10 to the power of 3 plus minus of 8.78 multiplied by 10 to the power of 12 multiplied by 1.5 10 to the power of minus 9. So I got the answer as 16830. So if I want to write in terms of 10 to the power of 3, what you will get, my dear? The unit for the speed is meter per second. So 16.8 multiplied by 10 to the power of 3 meter per second. So this is the answer for the first question. You can see my initial speed is greater than the final speed. My initial speed is 30 kilometer per second. That means 30 multiplied by 10 to the power of my plus 3. But my final speed is less than the initial speed. So my answer is correct. Clear, my dear? Clear?
Yes.
Yes, and because the acceleration is minus.
Because of the deceleration. Because of the deceleration, not acceleration.
Yeah, yes.
Clear? Okay. What is the second question? What is your second question?
How far
does the electron travel during this 1.5 nanosecond? My dear, we have one more equation. What is our fourth equation, my dear? If I go to write the fourth equation, what is our fourth equation? X, my easiest equation, which is nothing but V plus V naught over 2 multiplied by T. Am I right? So here, what is this? This is my distance. Am I right? So I can use the fourth equation for my V part. So D, which is equal to v plus v naught divided by 2 multiplied by t, and my initial speed is 30 multiplied by 10 to the power of 3. My final speed, sorry, my final speed is different. Sorry. What is my final speed? This is my final speed. What is my final speed? 16.8 10 to the power of 3. My final speed is 30 multiplied by 10 to the power of 3 divided by 2 multiplied by my time 1.5 10 to the power of minus 9. So what should be the answer? What should be my answer, my dear?
1 minute, I will go.
16.8 10 to the power of 3 plus 30 multiplied by 10 to the power of 3 divided by 2 multiplied by 1.5 10 to the power of minus 9. I got 3.51. Did you got that value? 3.51 multiplied by 10 to the power of minus 5, and the unit is meter. Suppose if I want to use the second equation is also working. You can see, because second equation, this is your d. X minus x naught is the d. You have initial speed, you have time, you have acceleration. So when you just substitute, you will get the answer. But the fourth equation is very easy. You can substitute directly. Clear, my dear?
Doctor, it's decelerating because the electron.
Yes, that's right.
Because the electron is moving in the same direction of the electrical field. When the electron is going in the same direction of the electrical field, its speed gets reduced.
Okay.
Clear?
Yes.
Okay. Then I think that's it. We have to go for the last question. It's a very easiest question. So you can just read the question, immediately you can give the answer. So an electron is accelerated eastward direction. What is the eastward direction, my dear? If you just draw the map, it has 4 directions: north, south, this one is east, this one is west. Am I right? So what is given here? An electron is accelerated in the eastward direction. That means the electron is moving in this direction. Am I right?
Yes.
Am I right or not? What happened to my cursor?
Yes, sir, yes.
My cursor got hanged. I don't know. Okay. So my electron is moving in the eastward direction. My dear, if the electron is moving in the eastward direction, what should be the direction of the electrical field?
In the west.
If the electron is moving in this direction means, sorry.
The opposite side, Doctor.
Ah, very good. So if the electron, for example, for the electron, if the electron is moving in this direction means what should be the what happened to my system? Okay, if the electron is moving in this direction, what should be the direction of the electrical field? My electrical field will be in this direction. Am I right?
The opposite side.
Okay. Now, my dear, you can see, if you consider the x-axis and y-axis, my x-axis is the positive value. This is my negative x-axis. Am I right? Am I right or not?
Yeah.
So could you please tell me the direction of the electrical field? Positive direction or negative direction?
Negative.
So
Negative.
you can see the second question. Determine the field direction. So what should be the answer for the B part?
Negative.
Negative direction, negative of x direction, or what happened? My screen. Negative of x direction or westward direction. Am I right?
Doctor,
right?
can you repeat it, please?
My dear, read the question first. What is given in the question? An electron is accelerated eastward direction. You can see my black color. You can see my black color. This is my electron. Am I right? Am I right?
Yes, doctor.
Electron is moving in the eastward direction. So that means the electron is moving in this direction. If electron is moving in this direction, what should be the direction of the electrical field?
The opposite side.
That means the electrical field is moving in the west direction. Am I right?
Yes.
That's what the answer for the B part, because they need the direction. So what should be the direction of the field? What should be the direction of the field?
West.
Westward direction or negative of x direction. Am I right?
Yes, you are.
Okay. Now, let's come for our A part. What is our A part? We have to find our magnitude. So how to find the magnitude, my dear? We know the rule. What is the rule? Because we know the formula, electrical field E, which is equal to force divided by charge. Am I right? Am I right?
Yes.
Okay. What is my force? My force, which is equal to mass multiplied by acceleration. Newton's second law. Am I right?
Yes.
Yes.
And this charge is the negative charge, electron. So what is my charge value?
Negative.
Positive or negative?
Negative.
Negative value. Very
Negative.
good. Now substitute the value. The mass of the electron is a constant. Yes, my dear.
Why negative?
What?
Why negative?
Because you can read the question, my dear. They tell you this is an electron. Electron is a positive charge or the negative charge.
Oh, okay.
Clear?
Yeah.
Okay. Now substitute the value here. The mass of the electron is 9.11. Is a constant. 10 to the power of minus 31. My acceleration is given in the question. 3.4 multiplied by 10 to the power of plus 9 and divided by my charge value is 1.6 multiplied by 10 to the power of minus 19. So when you work out, your answer will be for sure it will be negative because your electric field is moving in the negative direction. So your answer must be negative. So what should be the value? 9.11 10 to the power of minus 31 multiplied by 3.4 multiplied by 10 to the power of 9 minus of 1.6 10 to the power of minus 19. So what should be my answer? My answer is negative value of 0.01935. What's the unit? Newton per Coulomb. So this will be the answer. Clear, my dear? Clear?
Yes, doctor.
That's it. Chapter 22 is over. Chapter 22 is over. Now, I think what's the time, my dear? I think better we can just discuss chapter 23 tomorrow. Am I right?
Yes.
Yes,
Yes.
doctor.
23 because even I don't have the energy. Continuous class. So better we can stop by this question. I think this chapter is over. Inshallah, tomorrow we will start chapter number 23 freshly. Okay?
Okay.
Okay, thank you, doctor.
Doctor, the midterm until
Okay.
chapter 21, right?
Until chapter 21. So don't worry about chapter 22. Chapter
Inshallah,
22
Doctor,
chapter is not
will be
included. My dear, chapter 22 is not included in your midterm portion. So your midterm portion will be started from chapter number 16 to 21. And inshallah, next week is your midterm exam. There will be no class, there will be no lab. I'm talking about week number 8. But this week, you have the theory as well as the lab. And we will enter the attendance in the SIS. So you should be very, very careful. Please, my dear, if you are DN, I will not do anything. It's your mistake. Clear?
clear.
Clear,
Doctor,
my
I
dear?
have the question. Yeah, clear.
What question?
In chapter 18,
Okay.
there are more formula in one slide.
My dear, I can do one thing. My dear, listen carefully. I can do one thing. I gave the formula sheet in physics 1. Am I right?
Yes.
So likewise, I prepared inshallah by today night and then I will upload in the Blackboard. You can use that formula sheet for your preparation. No, please don't use that sheet during the exam. My dear, if you are using that sheet in the exam, you will be given 0 mark. I am just giving this slide for your revision.
Okay.
Okay, clear, doctor.
Clear?
Because Doctor, in one slide, it have like steps.
Which chapter? Which question? Which question?
Could you please go chapter 18?
Wait.
Doctor,
Wait, my dear. Yes, my dear.
what about backtracking?
My dear, that's what I said, my dear. Actually, last week we discussed in the meeting, and all the teachers we just say this information, and our chairman he forward the request to the deputy. I hope by 1 or 2 days we will get the clear information. Inshallah, once I get the information, I will pass the information in the blackboard as well as through the group. Okay?
Okay, thank you.
Don't worry. It will be always we think positive, and also be ready for
Teacher,
anything.
teacher,
Clear? Yes, my dear.
Doctor,
all
sorry.
questions, the midterm will be the same?
Same means?
All questions same, like...
My dear, we classified the question into 4 types. Knowledge part, easy part, medium part, and little bit difficult part. So the question will be coming like that. So my dear, listen carefully. So please see the mark and then give the answer very carefully. Because some question carries more mark, some question carries less mark. Okay. So please be careful while you choose the correct answer, and please work out the answer very carefully. Clear?
Clear, Doctor. Doctor,
Okay,
sorry.
my dear Abdullah, which slide?
Chapter 19, sorry. Not 18.
19 or 18?
19, sorry.
Why you said 18?
I get confused.
Okay, no problem, no problem. Okay, chapter number. Which question?
Here.
This one.
Yeah, yes,
Am I right?
yes, Doctor. Yeah.
My dear, this slide, I will tell you something, my dear. This formula is very, very important. Okay? This formula is very, very important.
Okay.
If the molar mass is given, you have to use this. Clear? Clear, my dear? And
Clear,
then
Doctor.
this formula is also very, very important. Sometimes, suppose if you ask, what is the RMS square value speed? Then you have to use this. And then this formula is also very, very important. Understand? And this
Doctor.
formula is also very, very important. My dear, it's depend upon the information given in the question. In the question, if you give the value of the Boltzmann constant, then you have to use this. Clear? Understand?
Clear.
Suppose in the question, if you give the molar mass, you have to use this formula. So please read the question and then try to choose the formula.
Here in this slide, 5 formula.
For example, you can see calculating the force is here. Am I right? Clear?
Yes, you're right.
And then here calculating the pressure, this one. Don't get confused about small m and capital M. What is small m? What is small m? Molecular mass. What is capital M?
Molar mass.
So please see this question. Small m is the molecular form. For example, calculating the force, you can only calculate with the help of the molecular mass. Suppose if you convert this molecular mass in terms of molar mass, the molar mass value will be given. So if everything is given, first of all, please write what is given and then choose the formula. So this formula is used for finding the force, and this formula is used to find the value of the pressure, and this formula is used to find the RMS speed in terms of molar mass, in terms of Boltzmann constant. Clear?
Clear. Here we have just 5 formula, right, Doctor?
5 or 4 formulas here. It's depend upon what is given in the question. Once you write what is given, you can easily get the formula.
Okay. What's about the 3 dimension here?
3 dimension. What 3 dimension?
In same slide, Doctor.
You're talking about this?
No. Go back, Doctor, to the slide. Here. For 3 dimension.
My dear, every time we have to go for every time, because the explanation initially I gave the explanation for x-axis, and then after that I just come for 3 dimensional. This n molecule is for 3 dimensional. Clear? Because here you can see we converted our 3 dimensional in terms of 1. Am I right or not?
Yes, you are right.
So initially I explained with 1 dimensional. After that I just combined everything because all sides are equal. So my velocity in x-axis, which is equal to y-axis, which is equal to z-axis. Am I right?
Yes, you are right.
So that's what I use this relation here.
Okay. Thank you, Doctor.
Clear? Clear, my dear? And the most important thing, my dear, the second important thing, please listen carefully. This value, suppose if it is not given, you have to memorize this. It's very, very important. Constant volume, monatomic this value, diatomic this value, polyatomic this value. Likewise,
We should keep
CV, sorry, CP, monatomic this value, diatomic this one. So all this information, because the formula sheet will not be given, so you should memorize many formulas from this chapter, especially chapter number 19 have many rules. Inshallah, I will do one thing. Today night I will prepare the formula for each chapter for your revision purpose. But you should not use that revision paper for your exam. My dear, while you scan, if you find the paper, then you will be given 0. So you should be very, very careful. Understand?
Okay. And
What did you
Doctor.
say, Doctor? Could you repeat?
My dear. My dear.
About scanning the paper.
My dear, actually, before you start the exam, you will scan the surroundings. Am I right? By using your camera.
Yes.
So when you just scanning the surroundings by using the camera, if any study material found in the table, it will be considered as 0 mark. So when you are about to write the exam, please make your table clean. Only the white paper and calculator. So we request the student to use the calculator on the system. But if you can't, you can use your external calculator, no issue. But if you have any study materials on the table, it will be considered as malpractice. We will put 0. So you should be very, very careful. Don't keep any study material, paper, book, whatever the things. Please don't keep it on your table. Clear?
Yes, clear.
Clear, Doctor.
My dear, listen, my dear, the system will proctoring you. Because the system will proctoring you based on your movement, based on your activity. So you should be very, very careful. And we will counter the number of flags given by the computer. If the number of flags will be more, then the marks will be given as 0. Because inshallah, maybe by this week, we will give the instruction. We will give the announcement in the blackboard. Please go and read. Once I gave the announcement regarding the midterm exam, please go and read the announcement in the blackboard. And we will give the clear information about your midterm exam, the rules and regulations. So please read the announcement very carefully. Clear? Clear, my dear?
Clear, Doctor.
Yes, clear.
That's it, my dear. I think today is enough. Inshallah, we will see you. We will just start discussing chapter number 23 tomorrow. Clear, my dear?
Clear, Doctor.
That's it.
Yes,
Thank you so
clear.
much. Now you can leave.
Thank you, Doctor.
Thank you, Doctor.
Assalamu alaikum. You're welcome, my dear. Assalamu alaikum.
Wa alaikum salam.